Good morning, everyone. Jerry Boyle is my name, Director of Teagasc, and it's my great privilege to welcome you all to this year's annual Dairy Conference with a difference. Over today and tomorrow, in one way or another, we'll be addressing what I call the sustainability challenge. And when we talk about sustainability in Teagasc, we think of it in four dimensions. The most important from my point of view is economic sustainability. In other words, every farm family out there wants to generate a reasonable profit to rear and educate their families. Social sustainability is also important. Environmental sustainability, as we all know, in turn has several dimensions. Greenhouse gas emissions, ammonia emissions, improvement in water quality, and improvement in biodiversity. So there certainly is a sustainability challenge, but I've absolutely no doubt that Irish dairy farmers can rise to that challenge. Look at what has been achieved over since the dairy quota was abolished. We've now dairy farmers have now increased milk production by over 70%. I've no doubt about it that energy, that hard work, that creativity, that innovation will equally be harnessed to address the sustainability challenge. But there's one thing very clear. We're going to face into a future with a lower use of chemical nitrogen. And I want to introduce to you a study that we're launching today. And I hope every dairy farmer out there gets the opportunity to read this over the next few weeks from cover to cover. It's a publication that's jointly edited by my colleagues Pat Dillon, Lawrence Chalou, Elodie Ruel, and Owen Fenton. And it does a number of things. First of all, it looks at the implications of a 20% cut in chemical N. And that demonstrates that net margin is likely to fall on a 40-hectare farm by between 7 and 10%. Clearly, that's a challenge. But what's most important, and what's evident from Teagasc research, supported by our advisory service, that there are solutions, and they're twofold. First of all, every dairy farmer out there can make better use of the nitrogen that they do use. The efficiency of nitrogen use is only 25%. I'd certainly be hoping that over the next 10 years or so, we can significantly increase that level of efficiency. That means every farmer can make better use of the nitrogen they do buy, and you'll have to buy less. And the second solution that has been demonstrated from countless experiments in Teagasc over the years, both here at Moore Park and at Clonakilty, is that the use of clover in the sward can significantly enable farmers to use less nitrogen. Up to 100 kilograms per hectare has been demonstrated in a research context. But we all know, of course, there is a clover challenge. There's a challenge in relation to persistency. There's a challenge in relation to soil type and so forth. But as I've said, with the backup of research and the backup of advisory service, we can deal with that challenge into the medium term. It's now my great pleasure to hand you over to Stan Lalor, I should say. And Stan is our new head of knowledge transfer in Teagasc. In fact, he's only a day in the job, and he'll be responsible in Teagasc for our entire advisory and education service. And Stan will moderate the first session. Over to you, Stan.
Okay, so good morning, everybody, and you're very welcome to this, the first session of the National Dairy Conference organised by Teagasc every year. It's a conference with a difference this year. This is the first of 4 sessions we'll be holding over the next 2 days. And on the next hour or so, we'll be taking on a very important topic in relation to the sustainability and the whole speculation and policy direction around the issue of nitrogen use on farms. I'm joined live here in Moore Park by our panel this morning consists of 3 of the editors of the nitrogen report, which is being launched this week. I'm joined here live in Moore Park by Dr. Lawrence Chalou, who is in the Livestock Systems Research Department here in Moore Park, also by Dr. Elodie Ruel, who works in the Grassland Research Department here in Moore Park, and also coming in from Johnstown Castle in Wexford with Professor Owen Fenton, who works on water and soil quality. So over the next hour, we'll be teasing out some of the aspects around how we tackle this issue around nitrogen fertilizer use efficiency on farms and what the research is telling us. As I mentioned, this is a very topical issue at the moment, driven a lot by developments on the policy front. And to begin our session this morning, we will go to a short clip by Jack Nolan, who is a Senior Inspector in the Department of Agriculture, who will set the scene for us on this topic in terms of the direction and what is happening at policy level, which is going to impact on this topic over the coming years.
Good morning, everybody. My name is Jack Nolan. I work in the Department of Agriculture in the area of water quality and biodiversity. You'll all have heard of the Green Deal and the Farm to Fork strategy. Over the next 10 years, we face some major challenges and opportunities on Irish farms. Part of it is to have 10% of our farms' agricultural area in areas for biodiversity by 2030. We're also going to be asked to reduce nutrient losses to water from agriculture by 50%. And this will probably result in a 20% reduction in fertiliser. Over the next few months, we're going to have the nitrates derogation review. For those of you that are derogation farmers, you know that this allows you a stocking rate of 250 kilos per hectare based on 85 kilos per cow. That 85 kilos is now going up to 89 from January the 1st. And if milk yield continues to increase, that 89 figure will again increase. We have to have a reduction in nitrogen use on Irish farms. There are several ways you can do this around soil fertility, liming, and better timing of application of fertiliser. We must make better use of our slurry. These are all opportunities, because what we want to do is to keep farming and keep producing produce that the consumer wants. So a challenge and a question to you all, can you reduce fertiliser nitrogen use next year by a half bag of urea or by a bag of can? Because we need to start making a difference straight away, not in 2 years' time, but from now on. Thank you.
So our thanks to Jack Nolan from the Department of Agriculture for that clip, which very clearly lays out some of the challenges that are going to be there, particularly coming from a policy perspective on how we manage nitrogen on our farms in the years ahead. To begin with this morning, I'm going to turn to my first question I'm going to put to you, Lawrence. Maybe you might just walk us through where we stand and what has been the pattern over the last 10 years. We know we've had a lot of dairy expansion. There are a lot of assumptions and perceptions out there about what that has meant for nitrogen and stocking rates and things like that. Maybe you might walk us through where we stand now in terms of nitrogen use on farms.
Thanks, Dan. I suppose, you know, as we look forward to the next decades, you know, we can learn a lot from the past decade. And I suppose if we just look at, you know, some of the stats, you know, over the past 10 years, we've had a phenomenal change in the dairy industry. You know, in 2015, milk quotas were removed. We had 35 years of milk quota up to that point. So, you know, the industry was in complete stagnation and there was huge built up capacity within the industry. And I suppose where we are today at ballpark 1.5 million cows is just where we were when quotas were brought in 1985. So it's almost like we're going back to the future. We're at that 1.5 million cows. One very important point that the Commission, the EU Commission made in 2008 when they flagged that milk quotas were going to be removed is that they wanted to see milk production move to areas of competitive comparative advantage. And country called out Ireland in that report. And that's basically what we're seeing. We're seeing significant growth in the dairy industry in Ireland because we have a competitive advantage, I suppose. And if we look at just some of the basic stats between 2010 and 2019, we've had a 65% increase in milk solids output, which is phenomenal. Obviously the biggest within the EU on a percentage basis. Cow numbers have increased by 40%. So a large proportion of that increase has come from milk yield per cow, about 40% in terms of milk yield per cow and about 60% from in terms of increased cow numbers. And a really interesting and a positive stat is where are those extra cows? And we can see that about 40% of those extra cows are facilitated by an increase in stocking rate. And I think it's really important that we draw out some and give positive recognition to some government policy around, for example, tax incentives for leasing, because that has allowed land to consolidate, and I suppose it has allowed land to move into different operations, and it allowed farmers to carry more cows without necessarily increasing stocking rate. So about 42% of it is being carried by increased stocking rate. Stocking rate gone up by about 13% from 1.8 to just over 2. And about 58% of the cows then are being carried on extra land. Really important stat is, key driver of the profitability of our business is grass utilized per hectare. And we're now utilizing about 1.3 tons more grass than we did in 2010, which is about a 25% increase in utilization. And of that 25% increase in utilization, the vast majority is coming from efficiency, better grazeland management, better efficiency rather than nitrogen. There's this perception that all the expansion has come from increased nitrogen. Not at all. About 70% of the increase is coming from better efficiency at farm level. And I suppose just two other stats then from the Teagasc Sustainability Report. When we look at the period 2014-2019, NUE, and you'll hear a lot about NUE as you go through the day, nitrogen use efficiency has increased by 10%. So that, we're improving our nitrogen use efficiency. And I suppose the amount of fat and protein corrected milk that we produce is also increasing relative to the surplus nitrogen. So there's a lot of positive stats in relation to what's happened with the last 10 years then.
Okay, so it's very clearly there has been an increase in dairying. There has been, I suppose, an increase to some degree in the nitrogen use, particularly in dairy farms, but efficiency is a big part of what has driven the progress as much as everything else. I should have said at the outset, we're coming live this morning. If anybody wants to send in questions as we go through this discussion, please feel free to submit those questions using the Q&A function on the Zoom facility as we go through the discussion. I will take as many of those questions over the course of the next hour as we can. Lawrence has set the scene a little bit in terms of the history already, but to go back into a little bit of the technical aspects of nitrogen for a minute and how that links into grass growth, you might maybe go back to first principles a little bit and outline, I suppose, first of all, the potential. We know we have a lot of potential to grow a lot of grass in Ireland. Maybe walk us through what are the drivers of that potential when it comes to grass production.
So I think firstly, if we want to remember about grass growth, what we really need to understand is that it's a big interaction of a lot of things. It's interaction between the weather, between the grass itself, between the soil, between the animal, and between the farmer. So all of that will interact together. But to go back to your question, everything actually starts by the potential growth of your grass. And that's depending on two main factors, the biomass on your paddock. So if the more grass you already have on your paddock, the more potentially it can grow. And on the sun. So how much sun do you have in the day? So obviously longer day and sunnier day means that potentially your grass can grow more. Then all that potential growth, we almost never achieve it, obviously, because it's going to be reduced then by different factors. And the main ones are, it's going to be reduced because of the weather, so of the temperature. So if it's too warm, like sometimes in summer in Ireland, not that often to be fair, it's going to reduce your potential growth. If it's too cold, like in the winter, it's going to reduce your that growth, so you will never achieve your potential growth. Then another very important factor, which is still linked to weather, it's the amount of water in your soil. Too much water is not good either, but if you are in a drought in the summer, then it's going to reduce that potential growth.
So that's the point of view from the potential of the grass, so that we can potentially grow a lot of grass. Weather is probably the biggest driver. Where does nitrogen fit in to actually whether we achieve that potential or not? Because that's the key issue here in terms of how we utilize nitrogen to achieve that potential.
So I guess now we have to look at the soil. So in your soil, you have two pools of nitrogen, which is the mineral nitrogen and the organic nitrogen. And the nitrogen which go into the grass is the mineral nitrogen. That's the nitrogen the grass can uptake. But you also already have organic nitrogen into your soil. And part of that organic nitrogen is actually mineralized to create mineral nitrogen. So that means that even your soil will be able to feed some nitrogen to your grass, even if you're putting no nitrogen, no fertilizer. But then obviously you have the nitrogen you're putting through fertilizer or through slurry. So slurry will actually increase both of your nitrogen pool, mineral and organic pool. And then you have also your animals. So the fact that you have animal grazing, that means you have urine and feces patches going back into the paddock. And so that means that a grazed paddock will grow faster than a cut paddock because you will, the animal will bring back some nitrogen into the system. However, so If we go back to our potential growth, if you do not have enough nitrogen in your soil, obviously you're going to limit that growth then. But depending when you are, you can have as much nitrogen as you want into your soil. If your temperature is wrong, or if the water in your soil is wrong, you won't grow as much. And one of the very worrying things we have to be very careful is if your temperature is wrong, if you're at the wrong time of the year, if you have a lot of nitrogen in your soil, but also a lot of water in your soil, then that's when you have nitrogen leaching, and that's what we want to avoid as much as possible.
Okay, so basically we have grass, it needs a lot of nitrogen to be able to grow,
yeah.
But nitrogen in the soil, as we know, is a very complicated system. It's available in a lot of different pools, and it's the relative availability of those pools and how soil type interacts over time, which all impacts on how much grass we actually do end up
yeah.
growing in the end. So that's a little bit of the theoretical information around nitrogen, how it works in the soil. But maybe bring that back from, maybe particularly from a farmer's perspective, looking at this morning and see, well, how much am I getting from the nitrogen that I'm spreading? What are the typical responses that we find for every kilo of nitrogen that we're applying in terms of grassland production?
Yeah, so that's once again depending on a lot of factors. But if we look at that slide, so you have two types of soil there. You have a free draining soil or an heavy soil. And if we go first looking at the annual response, we'll say, if you go between 100 and 150 kilograms of nitrogen per hectare, you may have a response which is around 20 for a free draining soil to 19 for a heavy soil. It will depend on your particular soil into your own farm. And if you do keep increasing the nitrogen, for example, if you go to 200 to 250, then your response is slightly lower. It's going to be 16 kilograms of dry matter per kilogram of nitrogen applied, but which is still a very good response. But the more nitrogen you put, the lower the response will be, because there is already a lot of nitrogen into your soil. So that's your annual response. Then, as I just said, in both slides anyway, the heavy soil have a small bit lower nitrogen response than the free draining soil. And that's for a very simple reason, is that most of the time heavy soil will have a small bit higher organic matter level into the soil. So that means they will have that means that there is more nitrogen already available for the grass to grow. So that's why the nitrogen response is a bit lower. Then what is very obvious from the slide is the variation between seasons, so between spring, summer, and autumn. And the response in summer will be way higher than in spring and autumn. And that just, if we go back to the previous slide, that's just because that's the time where the temperature is optimal and the day length is the longest, sorry. So that's when everything is perfect to try to reach that potential growth, as long as we are not in a drought situation. And in that case, the response in the drought year, the response will be way lower. While the response is highest in the summer, we have to remember a small bit that like grass, the spring and the autumn response are still fairly good. And that's when the grass is highly valuable. So we still get good response in spring and autumn.
So on average across the year, we can expect, depending on the soil type, that every kilo of nitrogen is growing maybe 15 to 20 kilos of grass.
Yeah.
But of course, that's highly variable versus spring versus summer and the value of that grass. And we'll come back to that point a little bit later. But to stick with, I suppose, that kind of more average figure for nitrogen use and the growth response to nitrogen, Lawrence. So I'll come back to you, and maybe particularly bringing in some of the results from the nitrogen report that's been published this week. You know, this potential, if we have a potential reduction in nitrogen fertilizer, particularly in line with the challenge that was set by Jack Nolan in his clip, what is the likely impact on that in terms of the farm systems, in terms of output on the one hand, but particularly profit?
Yeah, so I suppose that's the whole focus of the nitrogen report. I suppose it's in a response to a request from the Department of Ag in trying to understand what would the implications be from reducing chemical nitrogen. So basically what we did here was we took the information that LD had generated from her model around those responses. She talked 15 to 20 kilos of grass per kilo of nitrogen, and we wanted to look at what the impact that might be in terms of profitability. We looked at three scenarios. One scenario where we reduce cow numbers. If we put out less nitrogen, obviously you're going to grow less grass. So first scenario is we reduced cow numbers. The second scenario, we reduced cow numbers, but we held fixed costs. So the farmer that has invested heavily on their farm and has some fixed costs, those fixed costs won't reduce as cow numbers reduce. And the final scenario we looked at is where we keep cow numbers the same, but instead of we buy in supplementary feed. So we're displacing a feed, grazed grass, with a much higher cost feed. And when we look at the economics of that, we looked at a 10 and 20% reduction in chemical nitrogen. The 10% reduction in chemical nitrogen, depending on the scenario, reduced profitability somewhere between 3.5% and 5% in terms of profit per hectare. And if we look at a 20% reduction in chemical nitrogen, it reduced profitability somewhere of the order of 7.5% up to 10%, depending on the scenario. So where we hold cow numbers and buy into feed, it has the most negative effect. But probably the most likely scenario is where fixed costs are held, and it has somewhere between 8 and 10% of a reduction in profitability. We also looked at this from a beef and sheep point of view, and we got a very similar story. A significant 10, 12, 15% reduction in profitability in both beef and sheep systems when we reduce chemical nitrogen. And I suppose the final thing we looked at when we looked at the economic analysis, we looked at it from a greenhouse gas point of view and looked at the savings from a greenhouse gas point of view and costed the tons of carbon saved. And essentially it works out, depending on the scenario you take, at somewhere between 150 and 190 euros per ton of carbon saved when we modeled the impact of the greenhouse gas saving and the impact on profitability together.
So just by going in and saying we want to use less nitrogen as a singular objective is going to impact on farm profit. And that's where we need to come back and look at how we manage within that. And we'll come back to that in a moment. But I want to bring in at this stage Owen Fenton from Johnstone Castle in Wexford. And particularly now, I suppose, we've talked to Elodie, who has outlined why nitrogen is so important and why nitrogen is so valuable when it gets into grass, because it helps to achieve our grass growth potential. But I want to go to you now, Owen, and maybe you might walk us through some of the other aspects of nitrogen, which is that we know that not all of the nitrogen ends up in the grass. There's obviously efficiency factors in uptake and everything like that. And your research is very much focused on, I suppose, what happens to that nitrogen when it doesn't end up in grass in terms of some of particularly the environmental aspects, especially on water quality. So you might walk us through your take on that in terms of where that nitrogen is going.
Thanks very much, Stan, and hello to everyone. So, of course, nitrogen emissions, they're in different forms. Some, of course, are gaseous in terms of nitrous oxide, for example, or even dinitrogen gas. But I'm now really going to focus on below ground, okay? So you see a slide there, and I'm going to take a scenario of a nitrogen surplus. To me, nitrogen surplus is lost nitrogen, okay? But where does that loss go? We take an example of 200 kilos of N per hectare, and now we take 2 different soil types. So just think about your own farm. One field could be well drained, another part of your farm could be poorly drained, and everything in between, okay? But these are the 2 extremes, I suppose, Stan, right? So let's take the well-drained scenario. Here, a lovely well-drained soil allows water to move through the profile, but groundwater under your feet is quite deep, okay? And that allows nitrate to occur at high concentrations. So you get low overall protection here and high mobility. But now another part of the farm could have a poorly drained soil. Very different conditions here for nitrate loss. Okay, at about 1 meter down, you might have an artificial drainage system, and nitrate is converted to ammonium. That ammonium goes off in open drains to surface water bodies. But you still get a little bit of nitrate following through, but you have high groundwater protection overall with low mobility. So when we look at an agricultural landscape, I suppose, the world isn't flat. There's lots of different soil drainage classes right around us on our farm. Our neighbours have different soil types generally. And at catchment scale, that becomes more complicated. And then at national scale, of course, it becomes more complicated again. So look at the diagram there of a landscape. You've all these pinpricks. Each of those pinpricks will be delivering a different amount of nitrogen surplus to the groundwater. And everyone just look at that red arrow in the diagram. Focus on that. You can see there's a connection between nitrogen surplus, the groundwater that receives that nitrogen, but then there's a connection to a river. A lot of people don't know that. Groundwater and surface water are connected. So one feeds the other. In summer, where a river, you might be getting very low rainfall, the river still flows because it's been fed by that groundwater. And then that river flows to the estuaries or our coasts. We live on an island after all, so we really have to be cognizant of where the nitrate ends up, and that's in our estuaries. So we just move along there in the slide. Just to make the point that soils and weather are very, very important, and we have these nitrate vulnerable zones on our landscapes because of the differences in the soil types. We just move on to the next one. So what are the nitrate limits we're dealing with in these different water bodies? And if you just move on there, the boxes will pop up. They are very, very different, okay? So in groundwater, we're dealing with a drinking water standard, the water that comes out your tap. And that has to have a nitrate concentration of a maximum of 11.3 milligrams per litre of N, with an annual mean of 8.5. Now for freshwater systems like a river, there's a guideline value which is much lower. And you can see that there, 1.8 milligrams is used. And in high status areas, it's even about half that. But now let's go out to the estuary. Really, everyone has to think about an estuary is a composite. We all contribute to the nitrogen surplus and nitrate concentrations, but that all comes together to a point in our estuary, okay? So the European Union sets a guideline, a threshold here of 2.6 milligrams per litre as nitrate. And that's a very, very challenging water quality limit to adhere to. And my last point here is that how long is this going to take? When we talk about nitrate, remember there's a storage of nitrogen in our subsurface. So what we've done in the past affects water quality now. What we're doing now on a farm will affect water quality into the future, okay? So we have to manage our expectations here. It may take months to years for the nitrate concentrations to have an effect on the river or the estuary. But the big point here is that in our free draining areas, that takes a short amount of time, but that lag becomes a little bit longer as we move into the moderately drained soil types. And then the poorly drained soils, it can take much, much longer. Okay, so back to you, Stan.
Thanks, Owen. So very much a kind of a patchwork quilt scenario of you have all of these different individual subcomponents of the landscape in terms of various soil types, different systems, different stocking rates and everything like that, but all of them do contribute in some way to this composite end product, which is essentially the water that gets into the estuarine waters, and everything has an impact there. So I suppose that leads us then to, go back and look at those individual farms and the parts of the farm and think about the whole topic of nutrient use efficiency and how we might measure that. And we'll go now to a clip by Teagasc advisor William Birchall, who's based here in Cork and works out of the Moore Park Advisory Office. And William will walk us through, in his video clip, an outline of how this measure of nitrogen use efficiency can be measured on farm.
Nitrogen use efficiency is a relatively simple metric that can be used to see how well are we using nitrogen on our farms. So basically what it does is it looks at all of the nitrogen coming into our farms via fertiliser, meal, purchased forages and purchased stock. It then looks at what proportion of that nitrogen actually leaves the farm gate again and goes out as milk sales, forage sales and stock sales. So nitrogen use efficiency will do two things for us. Number one, it'll leave more money in our pockets as we'll be using our farm inputs more effectively. And number two, it'll reduce the potential for nitrogen losses to water and as emissions of ammonia and greenhouse gas emissions from our dairy farms. Now, currently, the national average nitrogen use efficiency in our dairy farms is 25%, and we would hope we can move that up to 35% in the coming years. So, nitrogen use efficiency, it is a good indicator of the overall sustainability of our farms, and the big thing about it is that it's a simple calculation that any dairy farmer can do, and it's a metric that farmers can use to benchmark off each other.
So our thanks to William Birchall for preparing that clip for us, outlining how nitrogen use efficiency can be a relatively straightforward measure to calculate on farm. Lawrence, I'll turn to you again, because you would have been involved in some of this development of measuring this nitrogen use efficiency, and it would come into your farm systems research. How have you worked or seen nitrogen use efficiency come in on the research side and the progress we can make there?
Yeah, so I suppose essentially what we've done is we're looking at a number of different technologies that can drive efficiency. And I suppose the first thing to make is the last 10 years and what the gains that have been made in the last 10 years are a signal to us that we can increase efficiency in terms of nitrogen use. So I suppose just looking at some of the stats that will come up in the slide here in a minute in relation to what are the technologies. And when you see the slide, you know, there isn't a massive amount of technologies there at present. And I suppose the most stark thing about that slide is the two things that are not coming up. One being grassland management. Probably the most important factor affecting NUE is grassland management. So if we look at the National Farm Survey, we estimate that farms are growing approximately 10 tonnes of grass. And in terms of pasture base, we know that farmers are growing on average 13 tonnes. So there's a 3 tonne difference there for a similar level of nitrogen. So that's the first thing. In terms of grassland, precision grassland management, better focus on you know, grass covers and grazing residuals, and measuring will be the first step. And you know, coming into that then will be sward renewal and I suppose soil fertility. It's not open, you know, it's you know, it's so big that it's very hard to pinpoint what an individual response will be to getting lime right, or getting P right, or getting K right, because every farm will be different and everyone will be in a different status. But the benefits are going to be huge in that light. So I suppose in terms of, you know, the big drivers then, and Jerry mentioned when he was doing the introduction, was clover. And I suppose we have a lot of studies done on clover over the last 10 years, both in Clonakilty and in Moorpark. And basically what they're showing is if you take it on the round and you summarize the data together, the clover will give a response of somewhere between 1.5 and 1.6 tonnes of dry matter per year. And obviously that doesn't come, that's not straightforward, it's not as simple. You know, there's a serious amount of management needed with the clover, but you know, it's fairly consistent across the studies. We have to reduce chemical nitrogen and so on to get it to stay in the swards, but there is significant evidence now to say that clover will certainly deliver in terms of that. And just to make the point that tonight, I think at 7 o'clock, there's a full session on clover, managing clover, getting clover into swards, and keeping clover in swards, which is really important. The next things that, you know, technologies we talk about are using slurry better. And, you know, when we talk about using slurry better, we're talking about using spring slurry, or using more of the slurry in the spring, and using low emission spreading technology like your trailing shoe or your dribble bar or your injector. And Stan, you'll be acutely aware based on your own research that there is significant benefits in terms of those technologies from increasing NUE and increasing response. So the figures that we estimate are that, you know, we can grow about another 300 to 400 kilos more grass by just getting the slurry right, by having it in the spring and using low emission spreading technology. The final one that, you know, I suppose the next technology that we talk about is urea with inhibitors, or stabilized urea, or protected urea, whatever you want to call it. And I suppose, you know, the research again is pretty solid on this, showing that there is no grass growth, no additional grass growth over CAN or urea in terms of what the benefit is in terms of increased grass growth. But, you know, if we go back to last Friday, the EPA had a report out on where the greenhouse gases were, and they said that agriculture, I think, it reduced emissions by 3.8%, which is really positive and needs to be called out. It's a real big positive. And they pointed out to lime reductions and nitrogen reductions. The use of protected urea has the potential to decouple the emissions, the greenhouse gas emissions from the use, because the emission factor, just talk about the emission factor for protected urea versus CAN, is 4 times less. So in essence, for the same level of fertilizer, if we move fully to protected urea, we'd have 4 times less emissions, which is huge in terms of greenhouse gas. And it's again a positive one from the overall story. And finally, just to finish up in terms of the technologies, I suppose, and it's one that doesn't come directly to our minds, but it is also very important. We all know that the organic N per cow was 85 since 1994. It's, you know, with a huge number of years, it just wasn't recalculated over that period. That will be increasing to 89 in the new year. And if we want to take control of that number changing over time as farmers, there is potential to do that by reducing crude protein in concentrate. And for every 1% reduction in crude protein in concentrate, we're reducing our organic N by 1.5 kilos of organic N, which is really, really big. So less crude protein in it's nitrogen coming into the system. So less crude protein in our concentrate has huge potential to reduce. And I suppose just a final point on that organic N and the crude protein in the concentrate, dairy farmers have made huge progress over the last 10 years in reducing the crude protein of concentrates, but there is scope to further reduce it.
No, it's great to see from the audience. We're starting to see some questions come in and related to some of the technologies you've just discussed, Lawrence. And not to take from, again, we have a full session tonight on clover, but one question has come in just to say, you know, clover has been around for quite some time in terms of its potential benefits to reduce nitrogen. What's our estimated level of clover content on dairy farms currently, and can this be increased? That's a question that has come in. Maybe Lawrence, you might quickly comment on that.
Yeah, and we'll be straight about it, Stan, the estimated level is low. So there is huge potential, you know, to take a guess at it's probably close to 5% or less. And really to get the benefits, as we've seen from the Moore Park and Clonakilty work, is we need 20 to 25% clover in our swards. And then that's when we get our real benefits. So I suppose, you know, and to be fair, we need to put a targeted program on the ground, but that'll take time to get clover levels up. And it's not just about getting the clover in day one. It's about getting the clover day one and managing clover, whether it's P&K, pH status, and managing it correctly in terms of, I suppose, trying to avoid poaching with it and better management during the mid-season.
Another question has come in relation to, I suppose, this end-use efficiency. And someone has asked the question, is 30% end-use efficiency target too low? Are we being ambitious enough, given the fact we're starting at 25%, 35 being the first step on the target? Are we too low? Are we right? Where's our ambition?
Yeah, and it's a very good question. And I suppose if we look at where we've come from, 2014, from the Teagasc report, we're at 22%. It's gone to 25 plus. And I suppose when we talk about the roadmaps, which are going to be talked about in tomorrow morning's dairy conference, we talk about 35% efficiency. And that's where our flagship system is into the future. And that 35% efficiency takes clover into account, takes the nitrogen that's coming from clover into account into the calculations. If we didn't take that into account, we'd be at 50% efficiency. So really important that we set our targets high enough and we put the technologies in place that we can deliver on those targets.
Okay. One of the technologies Lawrence mentioned was protected urea. And he mentioned that while it may not necessarily give us more grass per kilo of nitrogen, or maybe very marginal, the big benefit is in terms of the environmental emissions, in terms of ammonia emissions or greenhouse gas emissions, and the controlled ammonia emissions when we protect the urea or stabilize it in terms of the urease inhibitors and those technologies. We're going to go now to another clip from Anya Murray, who is a PhD student here in Moore Park. And Anya has been doing a lot of work around the whole topic around the confidence we can put in protected urea when we use it on farm, particularly comparing the grass growth responses that we get compared to our traditional nitrogen fertilizers such as CAN. So Anya will go through that now in this clip.
Hi, my name is Anya Murray and I'm a PhD student here at Teagasc Moore Park for my County Cork. As we are all aware, one of the major issues facing Irish agriculture is the requirement to reduce greenhouse gas emissions. While methane from ruminants receives a lot of attention, it is key to remember that nitrous oxide from the soils is a very important contributor to emissions from agriculture. Nitrous oxide as a greenhouse gas is approximately 300 times more potent than carbon dioxide. An effective and simple way for farmers to reduce their nitrous oxide emissions is to switch from using fertilizers such as CAN to a urea protected with NBPT. This protection also has the double benefit of cutting ammonia emissions, which improves air quality. One of the concerns with changing fertilizer types is that it may cause a reduction in sward performance. Therefore, over the last 2 years, we have been comparing grass growth and quality between swards receiving CAN, urea, and NBPT protected urea. This study was carried out as a plot study at 4 contrasting site locations. The plots were grazed by dairy cows here in Moore Park, along with Clonakilty, County Cork, and Ballyhaise, County Cavan. They were also grazed by sheep in Athenry, County Galway. This study showed there was no difference in annual herbage production between the 3 fertilizer types at any of the site locations. Urea plus NBPT has consistently produced the same pattern of grass growth as CAN across the year at all the 4 sites. We experienced no practical issues or concerns with using urea plus NBPT and see it as a key technology for Irish agriculture to reach its greenhouse gas emission targets. Reducing greenhouse gases from agriculture will mean farmers needing to adopt new ideas into their production system. It's as easy as switching your usual bag of CAN to NBPT urea fertilizer, which reduces nitrous oxide emissions by a massive 71%. That's a small change in practice for a large environmental benefit.
So our thanks to Anya for preparing that clip for us, showing some of the work that's been going on around the various Teagasc sites and research centres, showing the performance of protected urea in those trials. So we've touched a lot on some of the technologies that are available as Lawrence has gone through, but I'll go back to you, Elodie, maybe, and pick up on something you mentioned earlier, which was, we talked about the response to nitrogen, and particularly the fact that this response is quite variable at different times of the year. So if we go back maybe to the point that I suppose was put to us by Jack Nolan in his clip at the very start, and that idea or that target of saying, can we cut next year's nitrogen by half a bag of urea or a bag of can to try and make a difference in terms of the nitrogen that's being used, in terms of the targets that seem to be coming from a policy point of view. Where do we start next year in terms of the right place to go to start to cut this nitrogen, given what your research is showing in terms of these various responses at different times?
Okay, so I'm going to probably disappoint you, but there's actually no magical answer to that question. I don't have the magical answer on when should we cut nitrogen. So first of all, if I go back to those graphs, we need to remember that in the study we did there, it's actually a 16-year average of nitrogen response that is shown there using weather, which would be kind of moorpark weather. And that's using also, which is fairly important, a perfect soil fertility. So if your soil fertility is not perfect, your response will probably be lower. But by saying it's 16 years average, well, no. First of all, if we look at this, you could be thinking, okay, I need to cut my nitrogen in the spring and autumn because that's when the response is lower and I want to grow as much grass as I can, giving the nitrogen I have. But what we need to be really remembering is the extra grass you're growing in the summer actually goes into creating your silage. Okay, silage is very important because you need it to feed your cows during the winter and so on, or when there's grass shortage on the farm, but there's no real point to have extra silage stored in your farm. But any additional kilogram of nitrogen put in the spring or in the autumn actually go directly into the animal, so go directly to feed your animal, and that means that allows you to actually reduce the silage you're giving to the animal and reduce the concentrate you're feeding to the animal, so it's way more valuable. And we have done study with, well, Lawrence have done study which have shown that grass in the spring, an extra kilogram of grass in the spring is actually 5 times more valuable than one in the summer. So we need really to take that into account while answering or trying to answer this question. Then my second point is, as I said, is 16-year average. So every year your nitrogen response will be very different. So if we take 2 different springs, for example, you could have a very bad spring with very lots of rainfall on that spring and it's very cold. And in that case, your nitrogen response will probably not be at 13 or 12 or 10 kilograms of dry matter per kilogram of nitrogen applied. It will be lower. So maybe, especially, you need to remember, can you actually graze that grass? If you cannot graze that grass, maybe, yes, you can decrease nitrogen into the spring in those cases because that grass will not go into your cows, and you wait for the weather to actually improve. There's no point on putting nitrogen if Mediterranean is saying that there's going to be 50 millimeters of rainfall, which is going to fall in the 2 or 3 next days because it's actually going to be leached. So you need to look at your farm and to look at your weather forecast and what's happening. And you probably know also difference between your farm, your different paddock, which one are actually growing right now and which one are not growing, and you can take action on that. But then even in the simulation we have done, there was actually years where the nitrogen response in spring, because it was a warmer spring, maybe 2 or 3 degrees more than usual, lower rainfall, you could have response sometimes in the spring up to 20 kilograms of dry matter by kilogram of nitrogen applied. So in that case, I would definitely not cut nitrogen in the spring because that's very valuable grass. Once again, it goes directly into your animal. That means you need to feed less silage or less concentrate. So that means you actually need to create less silage in summer also because you did feed less silage. So that's my kind of answer, that I don't have an answer. Look at what's happening on your farm, know your soil type, have a plan, have a nitrogen plan in front of you, but be flexible and see what's happening out there.
So it's very clear that even though the response might not be as great in terms of grass growing in the spring, that grass remains to be very valuable. Yeah. I suppose it's important to find out as well at this stage, with this spring nitrogen application, it is very important to get that right in terms of the good practice around weather and timing and targeting the right fields and so on. Maybe Lawrence, bring you in again, from a farm systems perspective, on that question of, you know, where do you hold back the nitrogen the summer versus the spring, and where the grass is valuable? You have a lot of insight in that from your farm systems work.
Yeah, and I suppose the first thing I do, and I'd maybe be a little bit awkward and say that I wouldn't do what Jack asked you to do by taking out a bag of can. What I do is start by developing a plan, because I would be afraid that just ad hoc taking out a bag of can or a half bag of urea, going from one year to next, you could end up actually using more fertilizer. So I would say that it should be all part of a plan. There's no one saying that you don't do it, but you make it to be part of the plan. And part of that plan is around, you know, soil fertility, understanding where your soil fertility is at. And I want, you know, is there gaping holes here that we can use P or pH or lime or K to fill some grass growth deficits that might appear. And going back to LD's point about the spring or autumn, obviously we know that grass in the spring is very valuable and grass in the autumn is very valuable. So reducing nitrogen in that period may create a deficit that we don't want to see in our systems. So maybe there's scope to reduce some nitrogen, but obviously we wouldn't take out the full cycle. For me, the opportunities probably are going to center around silage. You know, what are the silage stocks like? Is there big silage stocks? Well, if there is, there's scope to potentially reduce chemical nitrogen in your silage, particularly, you know, if you over the last couple of years have wanted to cut silage and your nitrate levels are preventing you at particular points in May or whatever, that's something that maybe there's scope here to reduce around silage. And I suppose if we think about the mineralization and the value that we're going to get from clover that LD talked about, they're going to be more towards the mid-season and the later end of the year. So there is potential, I suppose, taking those into account from saving nitrogen. But just being very important, our competitive advantage is around grass and grazed grass. So we can't shorten our grazing season because that's going to add cost to our system. And you know, we brought out a report last week where we showed that Ireland has the lowest milk price in Europe. Our competitive advantage is only on costs, so we have to build on that and ensure that we don't damage our competitive advantage by management strategies that we put in place.
Yeah. So the other question which is coming in a lot in relation to, I suppose, this whole topic, we have some questions in from the audience, and maybe Owen, I'll go back to you maybe to kick us off on this one, is the question mark over not just nitrogen fertilization rates, but stocking rate. And we're very clear in terms of, you know, whole farm stocking rate limits, but I suppose more attention is coming now on the grazing platform in addition to the whole farm stocking rate. And I suppose link back to some of the things you mentioned earlier in terms of the different intensity levels in the landscape. Maybe outline for us why this area is in focus at all in terms of one part of the farm versus another.
Okay, very good question, Stan. So again, really it comes back to soil type and the nitrogen load. So there's a direct relationship between nitrogen load and nitrogen surplus. But so in other words, if you have a higher load on a vulnerable soil, that potentially could be worse off for water quality. But the complicated thing at farm level is that there is no direct link between, there's no linear link between surplus and water quality. So in other words, my point being that you have to look at the landscape, a catchment scale. You know, all parts of the farm, all different farms will be contributing to the nitrogen load. Some will be contributing more than others. Some parts of the farm will be contributing more than others. But you must match, I suppose, the protective ability of soil with that nitrogen load. That will then lead to nitrate levels in groundwater that are below those limits, and that will have positive knock-on effects for your river. And then of course, if everyone is contributing to a load that's below that threshold, that will lead to positive effects on the estuary eventually. The point I'm making about how long that takes is that we have a period of time, there's a transition here. What we've done in the past is still underground in storage, as it were. It's like an offshore account, okay, but unfortunately we can't tap into it. It's locked away. And we are now feeding that storage with our surpluses, and that storage then feeds water quality. So we have to look into the past a little bit, waiting for improvements to occur then with changes into the future will take time. And we all need, I suppose, a longer term commitment, a collective commitment to make that one concentration in the estuary improve.
So yeah, the kind of the balancing out across the whole country still does not, I suppose, remove the need to be careful in these maybe more intensive areas. Bringing that into your area, Lawrence, I suppose you'll be looking a lot about the optimization of farm systems in terms of not just the environmental aspects but the economics as well. Where does this stocking rate on the platform question versus the whole farm enter in from your perspective?
Yeah, and we've looked at it a number of times, Dan, in the last 10 years. And I suppose, first of all, we're going to publish roadmaps tomorrow that saying the stocking rate is somewhere around 2.7 is the optimum stocking rate. And I suppose, to have a stocking rate of 2.7, we need to be growing somewhere around 15 tons of grass. And to be honest, when we look at pasture-based data or look at any data, there's very few farmers that are in that zone. So that's the first point, is that the stocking rate should be directly related to what you're growing. And we shouldn't be, driving up stocking rate if we're not growing the grass, because essentially the feed for those cows, those additional cows, is coming from outside, and that's a cost. It's adding cost to the system. So first point is it should be related to grass growth. Second point is, from an economic point of view, and we've looked at this a number of times. We've done studies in Ballyhaise, stocked at 4.5 cows per hectare. There's studies going on in Salahead at the moment, looking at high stocking rates and bringing in feed. And those studies are consistently showing that if you include all the costs in terms of labour and all of the costs in those systems, those stocking rates are less profitable than staying on your, keeping your stocking rate in the platform. So where does the balance lie? And for me, the balance lies probably somewhere around bringing in at max 50% of your winter feed from outside. So the way to look at that is, if we have a system that we're growing 15 tons, we're utilizing 85%, that gives us somewhere around 12.7 tons of available feed. A cow will require 4.5 tons of grass or grass silage, so that'll allow us stock to 2.8 cows per hectare. If we take off half the winter feed, that's 0.6 of a ton, that'll bring us back to about 3.9. So 12.75 divided by 3.9 would allow us stock up to about 3.3 cows per hectare. So that's a 10 to 15% increase. And once you go beyond that, you're having a serious, negative financial impact on your business. And I suppose, why does it make, some people kind of have a perception that it makes sense. And just to be clear, this is not anything changed in the last 10 years. This has been our consistent message. I suppose that's when you include all your costs. If you don't include your own labor in that extra cows and extra work in that system, well, that might show some sort of a return. But that's the classic example of running faster to stand still. And obviously we don't want to see farmers doing that. Again, going back to the report that we launched last week around milk price and so on, again, our competitive advantage is on cost, not anything else. So we need to ensure that we stay and keep our system straight and manage our system based on that.
So in all things around the sustainability question, it's not just environmental enough, it's the whole financial, labour, all of those things kick in, and it's essentially a farm by farm plan. Is to be aware that there's an optimization required, and it's a farm by farm planning issue, really.
Absolutely. I
want to cut to some of the questions that are coming in. I want to acknowledge we are getting a number of questions around the topic of the protected urea question, particularly in relation to residues and things like that. That is an area of research that is ongoing in Teagasc that is being worked on. But I do want to acknowledge the questions and the interest in that topic. But I'm also getting a lot of questions on clover. And I will refer at this stage to the fact that we do have a full hour on clover tonight. So, but a couple of other questions which are interesting. One interesting one here is probably for you, Lawrence, again, is the cow breed and type. Questions come in. Is there a difference between the cow type and the cow breed in terms of the N emitted and the N efficiency?
Very good question. So, is there a difference in your organic N of individual cows? And it's a piece of work that there's a lot of work going on in it in New Zealand at the moment, and it's a piece of work that we're actively looking at now as well. And I suppose definitely in terms of, we look at organic N and look at the size of the cow, the milk production of the cow has a direct effect on the organic N of the cow. So, as we go forward, and why has 85 kilos become 89? That's because our milk yields have gone up and our cow has changed in the last 10, 15 years. And that trend is not changing. So that 89 kilos will be under pressure to increase again. And there are differences by individual cows, but they're probably relatively small. Nationally, we're going for one cow being 85 or 89. the question as we go forward and those numbers change, is there a reason why we need to start looking at different cows having different organic Ns? And maybe that's a debate that we need to have in the industry over the next number of years. But at the moment, the decision has been to stay with 1 organic N per cow, and that's an average cow. There are differences depending on milk yield, depending on the size of the cow.
There's one more question before we come to some concluding comments that I will take, and it's actually a point of clarification. And again, you're in the hot seat again, Lawrence. But it's just the message or the challenge maybe from Jack Nolan at the start around the bag of can, and is there mixed messages around we say hold on, keep spreading versus take on the challenge. But I think the message really is that we want to embrace this challenge of doing what needs to be done. But I think the main point is around the planning we can do around
it. So for me, it's about having the technologies to ensure that you're not disadvantaged from a profitability or a system point of view. So having a plan in place. My concern would be if you just tomorrow decide I'm going to drop a bag or next whenever, that it mightn't be something that's sustainable. You might end up actually putting more nitrogen on. So for me, it should be around developing a plan around the farm that fixes soil fertility, that has a plan to get clover into the system, and so on. And that challenge can potentially be met based on that then.
Yeah, and with a good plan in place, that's where you build in trying to achieve what we're trying to do. Just maybe I go around the panel just for maybe one brief wrap up question or comment just before we finish up. Maybe Owen, I'll start with you. I suppose the question here, you've talked about time lag, the fact that measures take time for the impact to appear and so on. But I suppose really one question I would put to you is there an opt-out here on the basis of all of that and the soil variability that in some places we can kind of continue to expand and work away, or what's your take on that in terms of the need for action?
Okay, thanks very much, Stan. So again, soil type is very important. In the free draining soils, that time lag is only months to very few years, okay? So these are the nitrate vulnerable zones. So even though there's a time lag, we should be seeing changes in water quality very, very quickly, okay? In other parts, in poorly drained, they may not have problems in terms of nitrate, but they would then have other issues in terms of phosphorus loss across overland flow pathways, etc. Okay, so when we're talking about nitrate, it's these nitrate vulnerable zones we really have to pay attention to. But my big point is that across an agricultural landscape, it's the collective, it's all of the nitrogen surpluses that contribute to water quality and have a knock-on effect to groundwater, surface water, and then eventually the estuaries. And that 2.6 milligrams per litre is a very low threshold in the estuaries.
And the need to, it will appear at some stage, and we do need to be looking at all of these systems. Elodie, quicker, I suppose, from your point of view, a farmer maybe looking at this morning says, okay, I'm going to try and do something. What would you say would be the simple, most important priority to do over the next couple of months, thinking about this and taking on this challenge next year?
I think what's very important is to have a plan. But to have a plan, you need to know your farm, know when your grass is normally growing. We have shown results from Moor Park weather. If I was showing you the same result for using Valley Haze weather, your spring nitrogen response is slightly lower because it's colder, but your summer nitrogen response is slightly higher. So would you change your plan if you were actually not in Moor Park but in Valley Haze? Know your farm, have a plan, know your different paddock, know which paddock will start growing faster each year. Maybe that's why you want to put the nitrogen, and maybe your lower paddock, you may put less nitrogen there or something else. But yeah, have a plan, but be flexible because everything will change each year. Your plan cannot be, you won't be perfect each year depending on what the weather we're getting. So you know your farm, you know what the average weather you're getting, you can create your plan that way, knowing your farm, and then be flexible.
And it's in that plan that you can build in where you target, target whatever technologies or measures you want to do. And finally, to you, Lawrence, I suppose, maybe looking from a farmer's perspective, maybe a farmer locked into a system, maybe between investment and things like that, maybe locked in, particularly maybe in more intensive systems, or a farmer maybe looking to go further and expand. What would be your concluding message there in terms of planning ahead in the context of this?
Yeah. So for me, first thing to say is that huge progress made in the last 10 years at farm level. And I suppose as we look forward, there will be greater constraints on stocking rate and there will be greater constraints on nitrogen fertilizer levels. So we need to embrace some of the technologies that are there. I suppose for the farmers that are planning and expansion or whatever in their different operations, you probably need to factor that in terms of some of these restrictions, in terms of the potential stocking rates that you might be thinking of. And for the farmers that have already, I suppose, capitalized and have high fixed costs, I suppose, focus on the efficiencies, the clovers, the low emission slurry spreading, the spring slurry, focus on those, and the grassland management. They're the technologies to focus on if you have those sunk costs.
Okay. So with that brings us to the end of our first session of this Teagasc National Dairy Conference 2020. Just a few quick thank yous before we end the transmission. I just want to say a thank you to all the production team who've put the facilities and the production together here in Moore Park this morning, and the live stream from Johnstown Castle. I want to thank the audience for your questions and your participation throughout the morning. We've dealt with some questions, and there are more which will carry over into the Clover session tonight. And we will come back to any questions that have been submitted over the coming days that we didn't get to deal with in the session itself. I want to thank the director for his opening comments, and I want to thank all of the panel, Elodie Durwell and Lawrence Chalou from Moore Park, and Owen Fenton, who joined us from Johnstown Castle. Thank you for your contributions. Also mentioned the video contributors, William Burchell, Anya Murray, and Jack Nolan from the Department of Agriculture. And finally, just to highlight that this is only the first of 4 sessions of our dairy conference. Tonight we resume with the Dairy Edge special broadcast at 7 o'clock. That will be a special session on clover, and that will include contributions from Dr. Michael Egan and from John McNamara, farmer in County Limerick. Then tomorrow morning we'll be back with our next session will be Dr. Karina Pierce, and that will be a session around the issue of sustainability through proven technologies. She will be joined by Dr. John Roach, who will be joining us from New Zealand, and also by Dr. Brendan Horn from Moore Park, and Brian Rush, a farmer from County Kildare. And then finally tomorrow evening at 7 o'clock we'll have another Dairy Edge special broadcast, and joining us on that will be Patrick Going from Teagasc and Dara Killeen, a dairy farmer from County Galway, and they will be addressing how efficiency targets can be used on farm to drive sustainability. So thank you for joining us, thank you for your attention, thank you to our panel, and we'll close this morning's session with that. Thank you.